Now we're starting our topic. So far, we have discussed welfare economics, the difference between partial equilibrium and I mean, general equilibrium. I hope you understand the difference between partial and general equilibrium. It would be great if you write a few points differentiating differences of partial and general equilibrium in your copy. I'm giving you 1 or 2 minutes, so it will be a recall from your side. I hope you have done and jot down some of the points of our last lecture. So we were discussing our new topic, which is pure exchange rate, where we are taking two people, two goods, and we will allocate their determine the allocation of goods. So the two peoples are Makkah and Susan. Two goods are foods and video. We put Makkah on the origin with the y-axis represented food and the x-axis representing video game. I'll show you in the next few slides how we have placed these on the axis. If we connect a flipped graph of Suzanne goods, we get an Edgeworth box where Y is all the food available and X is all the video games. What is Edgeworth box? It depicts the distribution of two goods of a two person between distribution of two goods in a two good world, two two-person world, right? This is Makkah food on your y-axis, video on your x-axis. If you flipped it, this is a box. If you it um, flipped it, it become like this, and this is Makkah side. I hope you remember in when you study microeconomics, you will take prizes on the y-axis and games on quantity on the x-axis. Now this is the same thing, but you are flipping it out. Then this become a Suzanne side, and this become a Makkah side, right? This is the x-axis of Suzanne. This is the y-axis of Suzanne. This is the x-axis of Makkah. This is the y-axis for um, I mean, this is the y-axis of Makkah, right? Total food in market is OR. This is the total food. Total video games is OS. This is video games, right? Each point in Edgeworth box represent one possible good allocation. This is the point which reflect the possible goods of allocation, right? On each point, every point on the in Edgeworth box. This box is called Edgeworth box. Edgeworth box, right? We can then add indifference curve to the Muskan's graph, each curve indicating all combination of goods with the same utility level. Curves farther from origin, the same concept we have discussed in microeconomics, where you can know that the farther the curve from the origin, the greater the utility you will get. For a review of indifference curve further to intermediate economics, you will discuss it in intermediate economics. We can then super impose Suzanne's utility curve. Curve farther from origin have O dash have a greater utility. Let's see how it looks like. This is food and this is video game for Makkah. Now this is for Suzanne and this is if we combine the Suzanne and Makkah, it becomes like this. This is the utility curve of Makkah. This is the utility curve of Suzanne. The farther from the origin, the greater the utility. From here, the farther the uh, indifference curve, the greater the utility, right? This, let's suppose this is the point where you can see two indifferent curves are intersecting. Suzanne has the highest utility level at S3. Uh, Makkah has the highest utility level at M3. ठीक है? Let's suppose Suzanne has utility of 2. Uh, Suppose some arbitrary distribution of food and games in this section. Let's suppose Makkah's indifference curve that Makkah's indifference curve, right, mm, is point at A, right? Uh, and and this is for the Makkah, and this is for the Suzanne, right? Um, is it possible to reallocate food and games between Makkah and Suzanne in such a way that Makkah is made better off while Suzanne is made no worse off? Is it possible? A moment thought suggests that such an allocation at point H, right? When Muskan is better off, Muskan will be better off because indifferent curve, the higher indifference curve representing the greater satisfaction level, right? On the other hand, Suzanne is no worse off. Suzanne will be no, because there's only one curve on I mean over here, since Suzanne will be no worse off because she is on her original indifference curve, right? I hope you get the point. Can Muskan welfare be further increased without doing any harm to Suzanne? As long as Muskan can be moved to indifference curve further to the northeast while still remaining on Suzanne S curve. Is it possible? This process can be continued until Muskan indifference curve is just touching S3, which occurs at point C in this figure. The only way to put Muskan on a higher indifference curve uh, than the M3 and M1 would be put um, Suzanne on lower point, right? An allocation such as point C, at which the only way to make one person better off is to make another uh, person worse off, is called Pareto efficient, right? This point is called Pareto efficient, where one person is better off without making other harming other one, right? There would be no harm if you reallocate your resources. Suzanne will be on the higher indifference curve and Makkah will also on the higher indifference curve. When all allocation is not Pareto efficient, it is wasteful. At least one person could be made better off. Pareto efficiency evaluates the desirability of an allocation. A Pareto improvement. What is improvement? A reallocation of resources that makes one person better off without making anyone else worse off, right? Like moving from A to C that we have discussed already in the last few slides. However, there may be more than one Pareto improvement. If we start at point A, C is Pareto improvement, right? A, then C will be a Pareto improvement that makes Makkah better. D is Pareto improvement that makes Suzanne better off. It makes Suzanne better off. B makes, because this is far from Suzanne's origin, and this C point is farther from Makkah's origin. So therefore, uh, this point makes Suzanne's better off. This point make Makkah's better off. E is a point that makes both better off. This is again farther from the origin. This is again farther from the origin. The E points is mutually Pareto improvement for both of the uh, parties. Now we will discuss contract curve. Assuming all possible starting point, we find all possible Pareto efficient points and join them to create a contract curve. Contract curve will tell you. I mean, this is the where you all where all the Pareto efficient points connected or joined. We said that if you join all the points, then it will consider as a contractor. Along the contractor opposing indifference curve are tangent to each other. Since the slope of the indifference curve is the willingness to trade or marginal rate of substitution along this contract curve. This would be the um, slope of Makkah, marginal rate of substitution of Makkah, marginal rate of substitution of Suzanne. Let's we stop over here and we will begin in the in next hour.